Hello friends, today we are going to solve LeetCode problem number 54201 matrix. In this problem, we are given m by n binary matrix, which means that all the values in the matrix are either 0 or 1, and we got to return the distance to the nearest 0 for each of the cell, okay? And each adjacent cell has a distance of 1 with each other, okay? So the distance between this cell and this cell is equals to 1, okay, and the distance with its own cell is equals to 0, okay. So let's look at this example here. As this cell already is equals to 0, so the distance to itself is 0, and hence the answer here is 0. The same is for all of these values. And what about this cell? So for this cell, the nearest 0 is to its adjacent cell, right? So the distance between these two adjacent cells is equals to 1, so that's why the result is 1, okay. And basically, if you would look at this clearly, if you noticed, what are we doing is we are looking at its adjacent cells, right? So it could be that all of these, three of these are 1, but only one of these is 0. So we look at all of these 4 adjacent cells at once, and we figure out the answer based on the value, okay. So that means that we are actually performing a breadth first search. Also, one more hint given to us is that find the distance of the nearest 0, okay. So nearest means breadth first search gives us the nearest value first, okay. So whenever we are given in the question like to find the nearest or to find the shortest distance, we use breadth first search, because that gives us the solution quickest way, and that is the shortest one, okay. Now let's take this example and also look at this over here. So we are given this binary this matrix, okay. So we have the value 0 here, so the distance between itself is equals to 0. So this is the resulting matrix, which is a DP matrix. And next we have a 0 2, so the distance between itself is 0. Similar is for this cell as well, and for this one too. Now we have a 1, so we got a 1 here. So what would the distance be for this cell? Well, to find a distance for this cell, we'll look at its adjacent cells, okay. So what are these adjacent cells? If we look, we are actually going to use the DP, okay. So for this one, we check the values in its adjacent cells, okay. So these two cells are empty, so basically we are going to fill it with some other values like -1 over here. So these two values are -1, so that doesn't count as an answer for us. However, these two cells are zeros, right? So we know that these two cells are zeros and these are the nearest ones, so that means this would be equals to 0 plus 1, which is equals to 1, and we are actually not considering these cells because these are -1, okay. So similarly for this cell, now we have the value 0, so we can actually write 0 over here, okay. Same now for this cell, okay. For this cell, it's equals to 1, so we want to find the value nearest to it, okay. So we look to its adjacent cells, and since this is -1, so we do not consider going that route. We look at this value, okay. And here we have a value equals to 0, so we take that value. And now for similarly for this one, okay, so this will actually be equals to 1. So similarly for this cell, now we look at its adjacent cells, and these two cells are equals to 1, so now this gives us a result equals to 2. And similarly for this one, now we look at its adjacent cells, and since the adjacent cells, one of them is equals to 0, so the distance will be 1, okay. 0 plus 1, we are taking the minimum of 2 and 0 and adding a 1 to it, so that gives us our answer. Now let's look at this in a little different way, okay. So I'm just going to change this example and add a 0 over here, okay. Instead of 1, we get a 0 over here. So if we are adding a 0 over here, and if we were to follow the same approach, then and what would be our answer in this case? Well, we are only computing this based on okay, so let me just go back a little. Okay, so now when we are computing this cell, we only are taking these two cells into account. We did not look at this position because we had a -1 here, right? And since we did not look, we only considered these two cells and we added a 1 to the minimum value and we got the value equals to 2, right? Now while we are calculating for this one, we see that it's equals to 0, so the distance here becomes equals to 0. Okay, however, now if you look at this cell, we are actually getting a wrong answer. It should not be 0 because the adjacent cell itself is 0, so that should be 1, right? So this approach that we are following is totally wrong and we need to update our approach. So how do we do that? So if we were to instead of starting from all of the values and checking for each of the ones, like performing BFS, like looking over each of the adjacent cells for the value which is equals to 1, what we do is we do a different approach. Okay, so here we are going to take the zeros and we are going to perform BFS around this value. Okay, so actually what need to happen is we should not start looking over its adjacent rows of this one. Instead, we are going to look at the neighbors of these. So the neighbors, just direct neighbors, should have distance of 1, and the further we go, the more the distance should increase, right? So we start from 0, and from 0, since this node already has a 0, so what we do is we update our DP for only the zeros. Okay, so these rows have zeros, right? These cells have zeros, so we have already updated the zeros for our DP. The rest of the cell will be filled with a -1, but for now I'm just going to keep them empty, okay, so that I do not have to keep erasing this now. And all of these cells will be stored in a queue so that we can perform a BFS approach. Okay, so these are stored in the queue. So now starting from the first cell which is stored in the queue, that will be this one, what we do is we perform a BFS for this. Okay, so we take this cell and then we look towards its adjacent cells. So the adjacent cell is equals to 0 here, and it is also equals to 0. So since we have already computed the DP for both the cells adjacent to it, we are not going to queue it anymore. We are only going to queue the cells for which we have not calculated the DP, and we want to calculate those DPs, right? So that is why. And looking for this one also, now we have 3 adjacent cells for these, 1 here, 1 down, and 1 towards the right. Okay, and as we look at our DP, we already have these two, so we are not going to compute the values for these two, but we are going to compute the value for this cell. Okay, and the value for this cell would be equals to the value from where this neighbor is arising plus 1. Okay, so since it's coming from this point, we will add a 1 to this value. Okay, so we get the value equals to 1. Now what we do is we add this to our queue. Okay, now we are adding this thing to our queue, so this cell goes to our queue. So in our queue we have this as first, we have this as second, this will go third, this will go fourth, this goes fifth because this is the fifth 0, and this goes sixth because this is the last 0. And now since we also updated the value of this one, now we are going to also insert this into our queue. Okay, So since we have already traversed this one in our queue and in this one also, now next is this cell, okay, and the adjacent cell for these are these two cells, right? But we have already computed the TP for these two, so we do not go ahead and we just move on with the next value in our queue, which is this one. And for this one, the adjacent cells are this, this, and this one, right? Now we check the DP for all of these three adjacent cells. This has already been computed, so we do not go ahead with that cell, and this cell has also been computed, right? So we do not do anything. Now for this cell, since it has not been computed, now we compute the value of this cell. So that would be the value of its neighbor plus 1, right? So that would be plus 1 equals to 1, and we computed the value of that cell. Now we push this cell to our queue again, okay? So now we have computed this. Now we move on to the next value in our queue, which is this one, right? This is the fifth one in our queue. So now here for this one, the adjacent nodes are these, right? These two are the adjacent cells, and we have already computed the value, so we do not do anything, and we move to the next cell, which is this one, which is sixth cell, and the neighbors are these and these, right? And since we have already computed the value for this one, we do not do anything. But for this cell, we do not have a value, right? It's an empty DP. So what we do is we calculate the value based on its neighbor, and we add a 1, so that would be equals to 1, okay? Now we have computed the value 1. So now next, this will be the last element to go in our DP. So basically, if you see, we have been adding all of these elements in our DP based on the order that we compute the value, okay? So now we have calculated the sixth one also. Now next in our queue, we have this cell, which is the seventh cell, and as you could see, we already have computed the values for all of its neighbors, so we do not do anything. Similar for this cell and for this cell, and finally our queue will be empty, and we also have found our DP, that is our resulting matrix, okay? So why am I naming this at DP? Because as you could see, like when we are performing breadth first search, we are choosing the value of the already computed node to calculate the value of its adjacent node, right? Adjacent cell. So that is why I just named it as DP. Let's look at this example here now. Since we have zeros at these cells, so we are just going to populate 0, because whenever we find 0, we just populate it, and then we also add these zeros to our queue. So we are going to add it based on the based on when we compute these values, right? So 1 2 3, and this will be 4. So this is the first one in our queue, so we pop this one and we calculate the DP, the value for its adjacent cells, and the adjacent cells are these two. And since we already have the value for this one, we calculate the value for this cell, which is equals to 1. So basically these goes around like this, and now similarly for this cell, it goes around like this, okay? So we are going to calculate the values for all of its adjacent cells. Since these two are computed, we do not do anything, but these two are not, and that would be equals to 1, right? Because we are adding a 1 to this node, so that gives us a value 1. And now that we have computed these two values, okay, and we will also be pushing these values since we computed this next. So that will be our fifth element, and then this will be sixth and seventh, okay? And next what we are going to do is we are going to move with this one, and this node, all of these adjacent cells have already been calculated, so we do not do anything. So next for this one, it's the same, so we don't do anything. Now we go with the fifth value, okay? So the fifth cell is this, and for this cell now, the adjacent node which has not been computed is this one, right? So we compute this, we add a 2, add a 1 to this value, and the value now here is equals to 2, and this becomes our next element in the queue, okay? So that's the 8th value. Now we move on to the next one, which is the 6th one. We computed the 5th, so now 6th one. For 6th, the adjacent element which is empty is this one, right? So we compute it, add a 1 to the result, and we get a value 2. Okay, so now that we have filled all the values, okay, so let's check, is it correct or not? Okay, so if you would look for this one, we need to go either this way or this way, right? So any of these is 1 2, 1 cell, 2 cell, or even this way 1 2. So that's 2, right? It's correct, absolutely correct. And similarly for this also it's 2, and for this it's only one distance to the nearest 0, right? So in this way we are actually able to find the nearest cell, nearest 0 cell. So now let's try to code our solution. So let m equals mat.length, n equals mat 0 dot length, and now we are going to iterate over. Okay, let us also create our queue where we are going to store all the indices of zeros. Okay, so let I equals to 0, I is less than m I plus plus, and let j equals 0, j is less than n j plus plus. Oh, so we need a for loop here too. And then if the matrix at this given cell is equals to 0, that is when we update our dp. Okay, so let us also create a dp array. Let dp equals to new array of length m, and we fill it with a value of -1, and again we map each of the cell to create an array to the array of length n and fill all of those with -1. Okay, now if the matrix at index ij is 0, then we fill our dp with the value 0, and now we push that to our queue. Okay, so we are pushing ij to our queue as well. Now that we have our queue, now we are going to perform our while operation, our BFS. So queue that length, as long as the queue is not empty, we are going to find our values at next index, right? So queue dot shift, so we are taking the first element from our queue, and we also need to look at all the 4 directions, right? All the 4 adjacent cells. So let us create a direction array. So 0 1 1 0 0 -1 and -1 0. Okay, now we are going to iterate over each of the direction. So let x equals to I plus d, and let y equals to j plus. Okay, so this is d0 and this is d1, and we need to check if x and y are valid indices. Okay, so x is less than 0, or x is greater than equals to m, or y is less than 0, or y is greater than equals to m. That means they are not valid, they do not represent a valid index. They go out of bound, and we just continue with the next calculation, right? Continue. Else what we do is we are now going to compute the value for that cell. So dp of x y would depend on its adjacent, right? So we are going to add 1 to the neighbor, right? So we are adding it, and now we push to our queue the value x y. Okay, and that's it. Finally we return our dp where we are going to store all the results. So let's try to run our code and check if it works. Okay, so we are getting an error. Okay, so what went wrong? While queue length, we are going to take the first element and we look at all the directions, okay, and if it is empty, okay, so we are only going to compute if the dp is empty, right? Okay, so that is also one thing we need to mark here. If dp at index x and y is already been computed is not equals to -1, then we do not want to compute it again, right? So we just continue. Okay, let's submit this now. Oh, so we got a wrong answer. Let's check where did we go wrong. So why? Ah, so this should be equals to n. Let's try this test case. Awesome, now let's submit this one. Great. So now talking about the time complexity, as we are iterating over each of the values of the cell, we have a time complexity of m times n here, and we are also performing a while loop for each of the values in the queue, right? And the queue could be of maximum length of n times m, right? So the time complexity and space complexity both are of m times n. I hope you liked my solution. If so, please like and subscribe. Thank you.